Hi, I'm Liren Zhou and my student ID is DSC2409020. This is my calculus assessment. While this is the contents, the number one is the applications of derivatives to economics. The number two is explain the washer method to find volume of a solid of revolution with one example. And the number three is explain moments and center of mass with one example. Well, let's go to the first part, the applications of derivatives to economics. The first function is the average revenue function. The question is, what's the average revenue functions? The average revenue of a firm is the amount of revenue earned per unit of output sold. It shows the efficiency of a business in generating revenue from each product or service sold. And there are some key features of average revenue functions. The number one is AR equals price if all units sold are sold at the same price. The number two is if the firm is a price taker. For example, a perfect complete AR is constant. The number three is in monopoly or monopolistic competition. It is nature that AR declines as more units are sold owing to the downward sloping demand curve. And here is the formula of average revenue function. We can know more about that from the formula. And why is the average revenue formula important? The average revenue formula plays a critical role in economic decision making for both business and policymaker. Here is some fact about average revenue. The first fact is pricing decisions. The second fact is market structure analysis. And the third fact is profit maximization. And the last fact is understanding electricity. Well, let's talk about the perfect function. The question is, what's the perfect function and what's the properties? A perfect function is a function that represents the perfect, that is generated by subtracting the cost for the revenue. The x-intercept of the perfect function is the break-even point of the function. It shows the point at which the amount of money that is spent to produce a product is the same as the amount of money that is received for selling the good or service. A perfect function has a domain for the set of all positive numbers, but can have a range that includes negative numbers. Well, the second question is, what's the formula for the perfect function? We can let Px represent the perfect function, and let Rx represent the revenue function, and let Cx represent the cost function. Then Px equals to Rx minus Cx. Well, the third question is why the perfect function is important. Because it equals total revenue minus total cost, and it is maximum when the firm's marginal revenue equals its marginal cost. Well, let's talk about the last function, the cost function. The first question is also that. What's the cost function? A cost function is a mathematical formula that can be used to calculate the total cost of production given a special amount of items produced. Second question is explain of a simple cost function. One of the simplest and most commonly used cost functions is the mean square error, which is referred to MSE, especially in rigorous tests. The MSE measures the average of the squares of the difference between predicted and actual value, and this is formula of MSE. Number 3 is how cost function works. A cost function, sometimes referred to as a loss function, serves as a measure of how far of a model's prediction are from the actual results. It is a fundamental tool in the training of machine learning models, guiding the optimization process to improve model performance. Well, let's go to the second part. Explain the washer method to find volume of a soil of revolution with one example. Well, what's the washer method? We can see the explanation of washer method. The washer method is one method of finding the volume of a soil of revolution. If a region R is revolved around the x-axis, then the volume is given by V equals to A to BX dx, where AX is the area of the face of a cross-section slide taken perpendicular to the x-axis. This is the same formula as used in the Dix method. However, the washer method implies that the cross-section face is a washer, a circle with a circular hole in the interior. The area of a washer is given by the area of the outer critical minus and area of the inner critical cycle, the hole. So AX 等于 pi R22 减 minor pi R12, where R2 is the radius of the outer circle and R1 is the radius of the hole. Well, we can see that this is an example. We can consider the region bounded about by the graph of the function fx equals to fx minus x and below by the graph of the function gx equals to gx equals to 1 over the interval 1 to 4. When this region is revolved around the x-axis, the result is a solid with a capital in the middle, and the slides are washers. The graph of a function and a representative washer are shown in figure 30A and B. The region of revolution and the resulting solid are shown in figure 13C and D. And this is the picture about 13 ABCD is here. Well, let's go to the last part, is also the third part. Explain moments and center of mass with one example. Well, we can picture a seesaw and two children are placed at opposite ends, an equal distance from the fulcrum. Now, if one child is bigger than the other, then the seesaw will tip. But if the distance and mass of both children are equal, then the seesaw will balance. And why? Because the mass is concentrated about one point, which concretes equilibrium. This point is called the center of mass, or the center of gravity, or the centering. And when we multiply the mass of a particle by its direct distance from the point, it's called to the movement of particle, and it measures the tangents of the path to produce a rotation about that point. And this is the formula about movement of the system about the y-axis ring and x-axis ring. Well, so our goal is to use definite integrals to find a point on a thin disk of any shape that balance horizontally. We will look at how a lever of seesaw balance objects, and how the formula must be moved in order to balance objects of different weights and mass. Next, we will then look at the formulas needed to calculate mass, moments, and the center of mass given uniform density. And we will see the connection that have to how we calculate error between two curves and the volume of thought of revolution. And these two are the formula. Which one is x coordinate and which one is y coordinate. My speaking is ended and thank you for listening. Bye bye.